Welcome back to the garage. Last time we got the exhaust tips installed, so I'll show you what we got going today. All right, the main reason for doing the exhaust tips now is I wanted to get this area underneath the seat taken care of and more finalized, because this area is about to get a lot more busy, so I didn't want to have all that stuff in the way to have to fish that muffler section out of there to finish up that welding. So now with that finished up, there's a plate that goes under the seat here that is going to mount a bunch of the electronics. You can see we got fuse boxes there. That's the main fuse panels. But in this less accessible area under the seat is going to be stuff like ground lugs, grounding blocks, binding posts for wires and such. So I think that's what we'll get going on today. I'm going to get that installed and then start laying out the wiring. So this is where I'm at right now. I basically have put the panel in and got all the main components in here, just laying in here and kind of laid out. And now begins the somewhat arduous task of figuring out the routing, where all the stuff's gonna go for the cleanliest installation. Once I kind of have everything laid out, like these components here, where they're gonna go, I need to mark and drill holes for actually mounting them. But I'm waiting like the longest possible time to drill holes until I have everything routed, so I know, where this stuff needs to go, if it's going to be better, positioned further over here, or, oriented a different way, or whatnot. So I'm not filming a whole lot of this because it's kind of just boring, but I'll take you through the process anyway. Here's where I'm at with the panel wiring. Every one of these components on here are now fastened down. So that's the kind of the final location of all this stuff. So I'm pretty happy with the location of all that. I don't think I'm gonna have any issues with the seat clearing any of this stuff. This is on kind of a downhill slope here, and there's covers that go on this, that plastic covers that cover all this up, these two. But even with the covers, I think the tops of these terminal screws are below the level of the bracket, so I don't think I'm gonna have any clearance issues there with the seat. So now at this point, it's just figuring out like the tidiest way to, you can see I already started zip tying some of the stuff together. So it's just going to be organizing it. I also started putting connectors on the wires that'll go to the rear steer pump. So that's what this little box is. This is a relay box that routes control wiring to the rear power steering pump, which is what this is. All right, I got something cool to show in this one. This is the main switch panel that goes in the center console. This controls just via standard toggle switches all of the accessories and such on the Buggy. And obviously I have ignition and start button. This panel I designed in CAD and cut it out with the plasma table. But what we're gonna work on now is making custom labeling for this. So I'm going to have this aluminum finish, but we're going to have each of, labels for each of these buttons, obviously. So what I got planned for that is this. So this is laser marking spray. So I have a laser engraver, and my plan is to design the labeling for this exact, basically pull the CAD for this panel into a vector graphics program, design all the labeling for all this, and then use my laser engraver to laser all of the labels. Now the way this stuff works, you spray this on and then the laser shoots the pattern into the material and causes this stuff to bond to the metal. And then afterwards you just wash off the rest, and what remains is the pattern that you've lasered. You can actually use this on other materials, metal, glass, ceramic. I have yet to actually try this out and test this, so we'll see how good it works. I'll probably start off with a small test piece of either preferably aluminum if I can find a piece of scrap that's just the right size, and that way we can dial in, the laser power and the speed and everything, get a good result, and then have those settings dialed in for doing the real one. And obviously I'll take all this apart and then laser that, and I'll show you that process, the laser engraver and everything. So here's the test piece. You can see I just printed the letters, particularly big letters. I only printed a couple letters because it was going to take a long time otherwise. So this is an X-Tool D1 20-watt diode laser. Right now I'm setting up the part in the machine. The laser has some crosshairs, and when I pulled the CAD for the switch panel, I purposely included the border specifically for this reason, for me being able to use it for framing. Even though the laser doesn't need to do anything with the border, having it in the model when I send it to the laser allows me to use that for framing. So the software has a framing capability that I'm executing right now, and you can see it following the border, and I'm just getting it precisely lined up. X-Tool has their own software that works pretty good, but right now I'm using a software called Lightburn, which seems to be more industry standard for laser engraving. Specifically when you want to do when you want to do more sophisticated things than the standard software allows you to do. Specifically, I wanted dimensional accuracy because in this case I'm actually lasering on something that I had accurate dimensions for. So if anyone cares about the specs, I'm running this at full power, so it's 20 watts at 7 millimeters per second. And that seemed to be pretty good speed for burning in this Ceramark spray. Since we're in the wood shop, I feel obligated to give you Norm Abrams' standard safety briefing. Don't forget to use these safety glasses that I just picked up. These are laser safety glasses for filtering out the laser light that would otherwise be damaging to your eyes. Here's the finished product. Came out pretty good for a first try. So you saw I just washed off the rest of it, and all the areas that the laser hit is cured on there. If I can get out of the shadow here, the logo has a few spots on the outline where the material didn't bond well. If I were to do it again, it's good enough to run with, but if I were to do it again, or if this wears out after time, I can make this again. And what I would change is I would add some thickness to the logo lines, so it stands a better chance of not coming off. But for a first try, custom made switch panel labeling, I think it looks pretty sweet. So if you look real close, you can see I tried to scratch it off just to see how resilient it is. You can scratch it off. It's not like a permanent, bond, but it's pretty durable. I think for all intents and purposes, it's going to be fine for the application, but I do have some ideas on what to do if it wears out really fast. Once you laser it on, you just wash it off, and the rest of this in the area that's not lasered, it just comes right off. I didn't wash the rest of this off because, I might experiment with, other things, play around with other things in different area of this, but different settings maybe. But a couple of other ideas that I had in case this wears off too easy is, this is aluminum, and I figure aluminum is easier to scratch than stainless steel, so it might actually be better on stainless steel. So I could try a piece of 304 stainless or something like that. So the other thing I thought of is I could take the switch panel and send the design off to a service like SendCut. Now I can cut the pattern myself. Obviously, I cut this one out on the plasma table, but if I send it to them and have them cut it, I think they do coating services. So if I could have them anodize it, I could have them anodize it black, and then I can use the laser to laser off the letters, and then you have kind of the reverse effect of black surface and then the aluminum, and then lasered off anodizing in the areas of the letters. So that's an option too. Might actually send it off, even if I'm not going to use it, I might even just send it off to them and see how that works, experiment with that, maybe have a couple of them made, and then I can just have spares if nothing else. So, and it'll be something else that I know about process-wise as far as that being an option in the future for future projects and stuff. So pretty cool. That's it for this one. Super cool to have this kind of capability with this laser engraver. Didn't come out perfect, obviously. There's some refinements to the process that I have to do and experiment with a few different, maybe different types of spray and speeds and feeds and thicknesses and whatnot, but I could perfect this, and this really opens the door for lots of cool opportunities for customizations. So thanks for watching.